All right, let's talk about a concept called carrying capacity. Carrying capacity can be thought of this way. Think of the ecosystem as a bucket. And in that bucket, we can fit only so much biomass before it overflows. And so if we think of our bucket filled with rocks, so we fill our bucket with all these big rocks that represent different predators, big predators. Then we can fit in there other smaller rocks in all the other spaces. And there's only so much space that these organisms can fill. So if we think of the predator niche as the big rocks and the pink as the prey niches, representing a variety of different kinds of organisms. And then imagine filling it in with a bunch of sand. And the sand would fill in all the gaps, and there would be a lot of sand filling in all those gaps. The sand would be like the producers. And so our bucket has all the niches filled with a variety of organisms, from producers to prey species to predator species. And then for predators, let's say there's lions, tigers, and bears. And each of these has a little bit different niche. And so they're not really competing with each other. They're competing within each species. The lions are competing with other lions, and the tigers are competing with other tigers, and the bears with other bears. There might be some competition across a species there, but for the most part, they're competing just within their own species. And then the same with the prey species. There might be 3 or 4 different kinds of prey species. And for the most part, they're competing with others in their same species, and then only somewhat with other species. The prey aren't competing with the predators. But the carrying capacity, then, is the amount of any organism that an ecosystem can hold. So our ecosystem here has a set carrying capacity. It has a maximum number of predators that it can hold, and a maximum number of prey that it can hold, and a maximum number of producers that it can hold. And what sets that maximum, then, is the resources. Let's think about a predator. What are the resources that the predator has to worry about? Well, food. That's the main one. So the prey that's available to the predator is a resource that helps set the carrying capacity. The more prey that could fit into this bucket, then the more predators could fit into the bucket as well. As the prey went up, the predators could go up. But also, what would set the carrying capacity for those predators would be shelter and water resources. So if those things went down, then the carrying capacity would go down. The carrying capacity is not fixed like a bucket. So our analogy here is a little bit flawed, and it's the same with the prey. What sets the carrying capacity for the prey? Well, the amount of food it has, the ability to find mates, the ability to find shelter, the ability to stay away from predators. So it's survival rate. And as one of these things change, then that affects the other thing and the other thing. They are all interconnected with each other, and it's the combination of those interactions and the limitations those all put on each other that set the carrying capacity for the ecosystem. And let's talk about a couple of different limiting factors. All these resources that set the carrying capacity are called limiting factors because they are factors that limit the carrying capacity. So pretty easy to remember that. And there's 2 kinds. There's density independent, and these are things that we can think of as usually like natural disasters. If there's a population of mice living in a valley, and that valley floods, those mice are going to die. And it's going to affect whether those mice were 100 mice per meter squared or one mouse per meter squared. They're going to die because they're going to drown. And so the density, remember this is our population density, is independent. That limiting factor, like a natural disaster, a flood, a hurricane, maybe a disease that comes through and can kill all of them, are density independent, because no matter if they are really packed in close together or really far apart with lots of space, the density is irrelevant. If the forest burns up, then all the small mammals in there are probably going to die, and it wouldn't matter if there was one of them or 100 of them all packed together. It's independent of that. Let's talk about the other kind of limiting factor, and we'll use a couple examples here. So this is density dependent. Limiting factors are limiting factors that are reliant on the density, and the more or the stronger influence is connected to the density, the stronger the influence on the carrying capacity. So bullfrogs, this is a bullfrog. Bullfrogs call at night with this rum sound. If one of them is in a pond and we have one bullfrog right here calling to the other female bullfrog over here in its rum sound, saying, hey, come over here. Then imagine we have an eagle flying around up here. That eagle's going to hear that sound and know right where that bullfrog is and be able to go get him. Now, if that bullfrog is in a clump with all the other bullfrogs spread all over the lake, and they're all calling at the same time, rum, rum, then that eagle isn't going to know where to zero in and find that bullfrog who is calling. So there's safety in numbers. This is a density-dependent limiting factor in the sense that the more of these there are, the more they're protected by being in those numbers. That affects their ability to hide from predators. So density-dependent. Another example is a disease. It could be independent, and that would be a disease that kills all the organisms no matter what. But a disease that is spread by contact could be a density-dependent factor. If one of these frogs gets the disease and it spreads by contact, then the closer together they are, then that's a disadvantage, and it would spread very quickly. So the more the limiting factor has an impact on the population because of density of that population, how closely packed together they are, then we call that a density-dependent limiting factor. Whereas if the impact on the carrying capacity is irrelevant to the density, like a natural disaster flood, then we call that a density-independent limiting factor. But the limiting factors affect the carrying capacity, and then the carrying capacity affects how many of the different kinds of organisms can fit into an ecosystem.